Okay, so today we're countering this integration question from the Hong Kong exams, and this one's frankly really straightforward and simple. So let's try to do it. So in part A, it's just by parts. There's nothing else to say really. So oops. So we have this is equal to that. We have whatever's here. So we have e to the power of a over a minus 1 over a. X squared 2x, and then put in there, so 2 over a squared. X e a x from 0 to 1 plus 2 over a 0 to 1 e a x 2 over a squared e a x dx, which means we have e to the power of a over a minus 2 to over a squared plus 2 over a squared e to the power of a minus 1. I believe should be an a cubed, not a squared, which means we have a squared minus 2a plus 2 e to the power of a minus 2 over a cubed, and that's exactly what part A needs, so that's over. B is we have to use a, so the obvious substitution is u equals natural 1 plus x. Yes, that one's the biggest hint. So we have oops, it should be e minus 1. And yep, that's the, well, u is natural log 1 plus x. So du is 1 over 1 plus x dx, which means dx is 1 plus x du, which is u du. Oops, that is wrong. That is e to the power of u du. And that's x, so we have from, and then obviously x equals 0 implies u equals 0. X equals e minus 1 implies u equals 1. So we have 0 to 1. X is 1 plus x minus 1. So we have 1 plus x is just e to the power of u. So u squared e2u du minus u squared eu du. And then we just use formula from part A. So we have 2 squared minus 2 times 2 plus 2 e to the power of 2 minus 2 over 2 cubed. That's a lot of 2's. Minus 1 squared minus 2 times 1 plus 2 e to the power of 1 minus 2 over 1 cubed. Which means we have 2e squared minus 2 over 8 is e squared minus 1 over 4 minus 1 minus 2, so that's just e minus 2. So we have e squared minus 4e plus 7 over 4, and that's it for part B. Part C and D, I believe we could just use part B and A. So we could do 2 substitutions. So I can't remember the question, so okay, cool. So 1 plus e minus 1 cos x squared sine 2x dx. We could have u equals this. So du is obviously 1 over that. And then we have e minus 1 So obviously we have the negative as well. E minus 1 sine x dx. And so this one is obviously 2 sine x cos x. So we could keep the sine x on the dx side. So we have sine x dx is negative 1 plus e minus 1 cos x over e minus 1 du. And this bracket right here is e to the power of u. Is that correct? Yeah, I think so. So sine x dx is and then we have a 2 here. Okay, we could just keep that there. So this one is negative e to the power of u over e minus 1 du. And then when x is 0, u is, I believe, cosine 0 is 1. So 1 plus e minus 1 is e, so u is 1. And x is pi over 2 implies u is 0. Because cosine pi over 2 is 0. So we have from 0 to 1, that's just u squared. And here we have 2 sine x cos x. So ignoring the sine x, we have 2 cos x. So we have an extra. So okay, let me calculate something. So cos x should be e to the power of u minus 1 over e minus 1. E to the power of u minus 1 over e minus. Yep, that's correct. So from 0 to 1 we have u squared. We have a 2. Cos x is e to u minus 1 over e minus 1. And then sine x dx is this thing, but then we flipped this part, so we have e to the power of u over e minus 1 du. So we have 2 times of 2 over e minus 1 squared. From 0 to 1, u squared times u squared e to u minus eu du. And that is just part b, but with a constant. So we could just do 2 over e minus 1 squared times e squared minus 4e plus 7 over 4, which is ignoring the brackets, we could just do this and call it the day for part C. And then part D, it is really similar. We could do the same substitution, I think. So from pi over 2 to pi. But this time we have a sine x, I think. E minus 1 of sine x. Sine 2x dx. So we could literally do the same thing. So let's go ahead and do that. 1 plus e minus 1 of sine x. So du again. And then we have e minus 1 cos x dx. We could keep the cos x on the dx side by doing this. So 1 plus e minus 1 sine x is e to the power of u. And then cos x is there, so we have e minus 1 here, du. And then so when x is pi over 2, u is sine pi over 2 is, sine pi over 2 is 1. So that is just 1. Oops, that's not a u, dang it. X is pi implies u is 0 because sine pi is 0. So we have from 1 to 0, 2u squared sine x. Let me write that down. Sine x is e to the power of u minus 1 over e minus 1. E to the power of u minus 1, e minus 1. And then cos x dx is eu e minus 1 du. So we have negative 2 from 0 to 1 u squared. Let's put the e minus 1 squared outside. Negative 2 u squared e2u minus eu du. And that is just the negative version of part C. So we could go ahead and just do this. And that's it for this question, which is quite easy, honestly.